In this lesson, we're going to continue on with our discussion in D10, universal gravitation, by talking about gravitational fields. A gravitational field is the space around an object with mass, how the space around is affected by that mass, and we can understand gravitational fields by looking at how objects that were placed around some massive object, how they would react. You would understand that if say a satellite was placed around Earth, it would feel gravitational attraction to the Earth. We would understand the attraction it feels to the mass it's near by understanding the gravitational field in that location due to the mass. When we define gravitational field strength, we define it as the gravitational force felt by a mass a certain distance away from that object, and the units of this are going to be newtons per kilogram, or amount of force per mass. Bear in mind that newtons per kilogram is an equivalent to meters per second squared. So an acceleration and a gravitational field strength both show the same amount of information. The equation we have for universal gravitation, or for gravitational field strength, is the lowercase g, which represents gravitational field strength, is equal to the gravitational force felt at that position divided by its mass. So let's do an example of gravitational field strength. At this location, a gravitational force with a magnitude of 250 newtons acts on a 50 kilogram astronaut. What I want to figure out is what's the gravitational field strength at this location. So we're going to start with our equation. Gravitational field strength is going to be equal to force of gravity divided by the mass. And then I put in the mass of the astronaut, 250 newtons, as well as having, or 250 newtons is the weight of the object, and then the mass of the object, which is 50 kilograms. The ratio of these two is going to be our gravitational field strength. And at this location, the astronaut is experiencing a gravitational field strength of 50 newtons per kilogram.